Hello students, in this video we are going to understand right angled triangle. So to understand trigonometry chapter, we need to understand the properties of right angled triangle. So if you understand this very well, then you will be able to understand trigonometry chapter easily. So let's focus on this. We are going to see a couple of examples and what are all the different types of sides available in the right angle triangle. Let's say I am giving an example here. Take a right angle triangle ABC is my right angle triangle where angle B is 90 degrees. So if you look at this particular triangle, AC is the highest length of the triangle. So when I say AC is the highest length of the triangle, that we will call it as hypotenuse. And here angle A is my acute angle. So you already know the definition of acute angle. So the angle which is less than 90 degrees is known as acute angle. And when I consider this angle, for this particular acute angle A, BC is the opposite side. BC is my opposite side and AB is the adjacent side. So now if you look at, when I consider this particular angle, understand it very carefully. When I consider this particular angle, opposite to this particular side will be my opposite side. Opposite to this particular angle, this BC is opposite side. And adjacent, so which is near to this angle, that is AB is your adjacent side. So now we understand the longest side is called as hypotenuse, and whatever the angle we consider, opposite side will be there and adjacent side will be there. For example, if I consider angle C, for this particular triangle, if I consider angle C, AB will be my opposite side and BC will be my adjacent side when I consider angle C. So you need to understand that concept very clearly. So let me give you another example. So before that, I just wrote what is AC, what is BC, what is AB in terms of angle A. So now if I give you another example, that is triangle PQR where angle Q is 90 degrees. That means it is a right angle triangle. In this triangle also, I wanted to check the opposite and adjacent sides for angle R. So when you say angle R, so what is the opposite side? Opposite to this particular angle is PQ. So PQ is your opposite side and QR is your adjacent side. And you already know the longest side, that is PR, in the right angle triangle is known as hypotenuse. So similarly, this is for angle PR. When I consider R, angle PRQ in the right angle triangle PQR. So similarly, if I consider angle P, so QR will be my opposite side. QR will be my opposite side and PQ will be my adjacent side. So this is how you need to understand what is your opposite side for that particular angle, what is your adjacent side for that particular angle. This is very, very important. So some people don't write the angle here. For example, here for angle A, I wrote the name of the angle as theta. So if I don't write, we will consider it as A only. We will call it as angle of A. So here if you see, they did not specify anything here. That's the reason we will call it as angle R. Okay, so hope you understand this concept clearly. Let's move on to the next one. In the next slide, what we are going to understand is another important thing, that is Pythagoras theorem, which you are already aware. So what is Pythagoras theorem? For a particular right angle triangle, the square of hypotenuse is equal to the sum of squares of opposite and adjacent sides. So that is what your Pythagoras theorem says. So in a right angle triangle, the square of the hypotenuse is equal to the sum of square of the other two sides. So this is one side and this is another side. So that means AC square is equal to AB square plus BC square. So that is what your Pythagoras theorem says. And also AB is the base. In this triangle, AB is my base and BC is, we will call it as altitude or height, and AC is hypotenuse. Now, if you look at the formula, AC square is equal to AB square plus BC square. Now, if I write AC is equal to then square root of AB plus BC. So, this is how your Pythagoras theorem will be derived, and you already aware of this theorem. So, this theorem will help you to identify different sides of the right angle triangle. How to identify those we will come to know in subsequent videos, and in the next slide we are going to understand a couple of more examples on the ratios. So we will see that also. So hope you understand the Pythagoras theorem. So simply you just need to understand in a right angle triangle, the hypotenuse, that is AC square, is equal to sum of AB square plus BC square. That means the other two sides squares sum will be equal to the square of the hypotenuse. So now what I am going to show you is ratios in right angled triangle. In a right angle triangle, you need to understand couple of ratios. The trigonometric ratios of the triangle ABC, where the angle at B and the angle of A is theta. So that is what I am going to show you in my picture. See, ABC is my triangle. The trigonometric ratios of the triangle ABC, where right angle at B. See, this is my right angle and angle of A is theta. See, this is what. So now what I am going to do is, I wanted to write the ratio. First one is sine of angle A. So you need to spell like this. Sine of angle A is equal to, so angle A, what I have given? Theta. So sine theta. So sine theta is equal to, the formula is length of the opposite side. Okay, the length of the opposite side to this angle. That is what I have written. So length of the side opposite to angle A by length of hypotenuse. So that means this one. So now if you see length of the opposite side to angle A, that is BC by AC. So sine theta is equal to BC by AC. So similarly, we have another ratio, that is cosine of angle A. We will call it as cosine of cosine. Some people call it as cosine, some people call it as cosine, whatever, but ultimately you can call it as cosine of angle A is equal to, angle A is theta, right? So we can simply write it as cos theta. So maximum whenever we work in mathematics, trigonometry chapters, we will write only these names: sin theta, cos theta. We will not use sine of angle A, cosine of angle A, all these things we don't use. So just to make you understand, I am writing from the beginning. Okay, cos theta is equal to, so when you talk about cos theta, now the length of the adjacent side to angle A, that means length of the side adjacent to angle A, that is AB by length of hypotenuse. So that is AB by AC. This is what, so cos theta. And the next one is tangent of angle A. So tangent of angle A, where angle A is theta, we will call it as tan theta. So tan theta means, so the opposite side of this particular angle A by the adjacent side. That means length of the side opposite to angle A by length of the side adjacent to angle A, that is BC by AB. So these are the main ratios, and we have three more ratios. We are going to see those as well. So now hope you understand, when you are talking about sin theta, it will talk about opposite side by hypotenuse. Cos theta means adjacent side by hypotenuse. When you talk about tan theta, we will call it as opposite side by adjacent side. So you will also learn in future tan theta is equal to sin theta by cos theta. So when you make use of this particular value by this particular value, see here, length of the opposite side to angle A by length of the opposite hypotenuse by divided by this value, So hypotenuse, this will get cancelled. Then length of the opposite side to angle A by length of the opposite adjacent side to angle A. That is what your tan theta. So don't worry about it if you don't understand. So simply understand tan theta is equal to sin theta by cos theta. Okay. So we will see that in the next slides. So next ratios, we have the same definition. I have taken the angle B as 90 degrees and where angle A is theta. So in this case, we have these, we will call it as reverses of the first three. So when you call about cosecant theta, we will call it as cosecant theta. So cosecant theta is equal to 1 by sin theta. So 1 by sin theta means the inverse function of sin is called cosecant theta. Okay, so cosecant theta, when you talk about cosecant theta, it will be like hypotenuse by opposite side. We will see that also. Okay, and secant theta is reverse of cos theta. That means secant theta can be written as secant theta is equal to 1 by cos theta. So cos theta reverse means here secant theta means hypotenuse by adjacent side. Okay, and also tangent theta, tan theta is equal to sin theta by cos theta, and also cotangent theta, we will call it as cot theta. So cot theta, it is cos theta by sin theta. So these are the very important ratios which you need to understand before you go and understand trigonometry chapter. Now if you look at reverse ratios, just now what we have discussed, the cosecant, secant and cot. Cosecant theta is equal to, as I already told you, hypotenuse by opposite side to angle A, that is AC by BC. See here, this is your angle, this is your opposite, then hypotenuse, and then this by opposite side. But in terms of secant theta, in terms of sin theta, this will be reverse, right? Opposite side to angle A by hypotenuse will come. That's the reason cosecant theta is a reverse of secant theta. And similarly, secant theta, here you will see hypotenuse by adjacent side to angle A, that is AC by AB. And similarly, cot theta is reverse of your tangent. That means adjacent side to angle A by opposite side to angle A. That is AB, adjacent side to angle A. So here it is wrong. Adjacent side to angle A is AB. Here it is AB by opposite side BC. So I just made a mistake here. So cot theta, it will be in the reverse order. Okay.